Now during this session we're going to take a review of the TCP IP protocol. Now once again, this is a review. We're not going to go heavily in depth on the TCP IP protocol at this point because a lot of this stuff you should already know if you have some networking experience. However, we will cover the basics during this session, and as we go through the course we're going to touch on other elements as well. So we will be going more in depth on TCP IP as we go. First of all, you should probably know already that protocols are rules for communications on a network or between two computers. In other words, there has to be some rules for communication that state who will send packets first, who will correct errors, how many retries there will be, and so forth. These rules have to be set up, and that's what protocols are for. Now, the Transmission Control Protocol, or an Internet Protocol, or TCP/IP as we call it, is a protocol stack or suite, and it groups many different related protocols together within this stack. Now, each of these protocols work together with each other. They perform specific functions, but they also interrelate and depend on each other as well within the standard. Now, TCP/IP is the most popular model. It's the most widely used protocol stack out there. It's the de facto standard, in fact. Now, why is this? Well, it's simple. It's because for years TCP/IP was the protocol used during the ARPANET years, and when the Internet came into being, when it progressed from the ARPANET to the Internet, TCP/IP was already known and reliable and well used. Computers were already set up to use it. So it's used for a lot of connections within most networks that you have out there today, and it has to be used to connect to the worldwide Internet because that is the standard. Now, as you may remember before, when we talked about the OSI model, it was a 7-layer model. And the OSI model is different from the TCP IP protocol. Let's get that straight. The OSI model basically tells you how all protocols should work together within a network, how things ought to work. It's just a model, a concept. The TCP IP protocol, on the other hand, can be viewed as a model as well, but it's an actual in-use protocol stack. And basically, it corresponds or complies with the OSI model, the OSI way of doing things. And you'll find that TCP IP covers most of the popular protocols used out there on the Internet today in daily and network communications. And we'll go over the particular protocols in another session, but some examples would be mail, SMTP, the World Wide Web, HTTP, and so forth. But it does correspond with the 7-layer OSI model, so it's actually very easy to understand, and we'll look at that in just a moment. The 4 layers of the TCP/IP protocol stack are the application layer, the transport layer, the internet layer, and the network access layer. So you might be asking yourself, well, what do these do in relation to the OSI model? Where does my web browsing take place? Where does encryption take place, and so forth? And we'll go through that as we go through the course. First of all, though, let's take a quick look at how the TCP/IP model corresponds with the OSI model, just so you can get a good frame of reference. Now, at the top of the TCP/IP stack, we have the application layer. Now, it directly corresponds with the top 3 layers of the OSI models, layers 7, 6, and 5. So the application layer, whatever happens at the application, presentation, and session layer on the OSI side, all that stuff happens on the application side of the TCP/IP model. So you have web browsing, email, encryption, session establishment and breakdown. All those things happen in the first layer of the TCP/IP model. The next layer that you have in both stacks is the transport layer, and they pretty much correspond 1-to-1. They both provide for connection-based and connectionless transport. In fact, the TCP and UDP protocols take place at this layer in the TCP/IP stack. The next layer, although known by different names, basically performs the same function. The network layer, as we remember from our discussion on the OSI model, covers IP addressing and routing. In other words, finding a way to the destination. The internet layer on the TCP/IP model side does exactly the same thing. Some protocols that you'll find at the internet layer include ICMP, IP, IPsec, and so forth. And we'll talk about more of these protocols later. The next protocol layer down, or the next layer down rather, in the TCP/IP model is the network access layer. Now, if you look across the side of the slide, it directly corresponds to the bottom 2 layers, layers 1 and 2, of the 7-layer OSI model. We have the data link layer, which we know is responsible for putting frames on the wire. And then we have the physical layer, which we know is responsible for sending the bits and bytes, the electrical signals and impulses back and forth across the wire. These 2 layers correspond directly to the network access layer. Now, I know all this might be a little bit much at first, but we're primarily going to be using the TCP IP model throughout this course. We wanted to show you what the difference is between these two, between the model and the TCP IP stack, so you could get a good frame of reference and understand what the difference is. Now we're going to look a little bit later at the particular protocols that take place at each layer of the TCP IP model.